All right, let's do a problem that might look a little difficult until you realize you just need the right formula. So it says an object travels a distance of 360 meters while coming to a stop from 60 meters per second. What is the object's acceleration? All right, well, we know that we're supposed to find the object's acceleration, so that's what I'm going to start with as my question. I know that the object travels a distance of 360 meters. Now it's coming to a stop, so it's got an initial speed of 60. So I know that my VI, or my V0, is 60 meters per second. And I know that my final velocity is 0 meters per second because I'm at a stop. All right, so we're normally using something that involves time when we do a problem like this. But you do have a formula that you can use that doesn't have a time component. And that general formula is usually VF squared equals V naught squared plus 2 times the acceleration times the distance. Now I do like to rearrange my formula, so I'm going to solve this for acceleration because that's what I want. I just think it's simpler that way. So when I rearrange it, I get the acceleration is equal to VF squared minus V naught squared over 2 times D. Now I can simply just plug numbers straight into this thing. So I'm going to go ahead and go over here. My final velocity squared is 0 meters per second. And I'm going to do the quantity squared there, minus 60 meters per second, quantity squared, divided by 2 times 360 meters. And then I'm going to bring this across. Put a separator there. 0 meters per 0 squared is 0 meters squared per second squared. Well, that just goes away. So I have negative 60 squared should be 3,600. 3,600. I not only have to square the number, but the units, meters squared and seconds squared. Then I'm going to divide that by 2 times 360. That's 720 meters. Okay. So when I take negative 3,600 divided by 720, I get, now that's a negative sign, so that's negative 5. And then I have meters squared per second squared divided by meters. And if you go through the unit cancellation, this meter cancels because it's like meters over 1. And one of these meters cancels, and I'm left with meters over seconds squared. And then I have 2 checks on this problem. One is I'm asked to find an acceleration, and my units come out in meters per second squared with the proper unit cancellation. So that's one check that I have here. And then this object is coming to a stop, which means it's slowing down, which means it should have a negative acceleration. And when we do the math here, we do indeed end up with a negative. So this object had an acceleration of negative 5 meters per second squared.